All right, I'm going to do a quick reintroduction into the if-else control structure and adding the else-if in between the if and the else. So that would be if, else-if, else. And I'll put the parentheses in here to let you know that these have conditions and the final else doesn't. So what this control structure allows you to do is run certain code only at certain times. So if a value is entered in, and if that value is within a certain range, then run a certain block of code. So real quickly, int, I'll put UI for user input. I'm not going to set it to anything. I'm going to prompt the user. Printf enter an integer. And then I'll save it to the UI variable by using %d ampersand UI. Don't forget the ampersand for scanfs. So now you've stored that value that the user entered through the keyboard using scanf. You stored it into UI. So now we can check the value of UI in these if conditions. So let's say if the user entered in a value that is less than 0, we're going to say something like UI is less than 0. We want to do something. So in this case, we'll say printf, you entered in a negative value. So what if they enter in something greater than 0? Well, we can write it like this, like we used to. Printf, you entered in a positive value, like so. And then, if it's not positive or negative, if it's not greater than or less than 0, it must be 0. So if UI is equal to 0, printf, you entered in 0. Okay, so let's just give that a try. Run it, give it a positive number, a negative number, and give it 0. Okay, great. So how can we restructure this? Well, it can't be all three of these at the same time, right? It's either going to be this one, or this one. So with that, we can actually restructure this into an if, else if, and an else. So we can take this and rewrite it as such. So I'm going to just copy this and move it down here. Okay, so we can do the normal thing here. We'll check this first condition. If it's not this, else check if it's greater than 0. So now this structure is connected to each other. If you get into here, if this first condition is true, this condition will not be checked at all. It'll be completely skipped. And then finally, we can add another else if here to connect it. But you're either less than, greater than, or equal to 0. If there's only one possibility left, you can actually just turn this into an else. So here's the equivalent structure for 3 different ifs. Now, the way the code will work, as previously mentioned, it goes top bottom, right? So when the program starts, it starts at the main. It says we get the UI here. We're going to prompt the user to enter in an integer. We store the value into UI using scanf, and that takes it from the keyboard. The first thing it does is checks, is UI less than 0? If it's not, it jumps straight to here. If UI is greater than 0, then, let's say it is, it will print this and totally ignore this else. Now, continuing on, since I said it was greater than 0, it will check this. It's not true. Then it'll jump here and check this. It'll print this out because I just said in the example it's greater than 0. Then it'll jump here and check it again. when it didn't need to, right? We already knew that it was greater than 0, so this check doesn't even need to happen. So you can save computation by using an if, else structure. So I'm going to show you, we're going to write a program in the next part of the video using else if statements in like a menu format, and hopefully that'll help clarify what's going on there. And we'll also apply what we've been learning in class, and please follow along when you watch the video if at all possible. So for this particular video, we're going to make a little program that is similar to our in-class assignment, where we just kind of, or even our homework, I can't remember. Basically, it'll add, subtract, divide, or modulo, find the remainder, for two numbers that get entered in by the user. We'll create a menu that kind of looks like this. They'll choose which one they want, and whichever one they choose will provide the answer to the screen and end the program. So here's the goals up here. Ask the user to enter in two numbers, so we're going to store those numbers, and then display a menu such that they can perform an arithmetic procedure on that input. Then prompt them to choose something from that menu, and then run the algorithm, or calculate the expression, and present the answer to the screen and end the program. So at this point, I want you to think about how you're going to do this approach. So if we're doing arithmetic operations with two numbers, we can easily store the answer into its own variable. What kind of types are we looking at here? Do we want floats, ints, or doubles? With floats and doubles, we're able to give better precision with numbers that become fractions, right? While ints are just kind of stuck to whole numbers. So we'll more than likely need two variables for the user input for those first two numbers, and then we can make a third for the storage of the answer. So pause the video, think about how you really want to do this. And then what about for the menu itself? Should it have a separate variable for its input? So this is where you're thinking, okay, do I want to ask the user for the user input first? For the two numbers first? Do I want to show the menu first? These are design decisions that you can make, or, a lot of the times a client will come up to you and tell you this is how I want it to run. But right now, you're the client as well. You figure out what kind of order you want it in. So I'll give a second here for you to pause and for you to think about it and draw your little flow chart. All right, so I'm going to just go ahead and jump in. I'm just going to say for this video, we're going to ask the user first for the two numbers. Then we're going to pop up the menu, and from that menu, we want them to choose which operation they want done on those two numbers, and display the answer, then end the program. So I like to solve these problems just one chunk at a time. So the first chunk I see in my mind is we need to get the user input. So when we get the user input, we obviously need variables. Well, if we need variables, we obviously need to declare them first. So here we go. Let's declare three variables right now. I'm going to use the type double just to get you acquainted with it. We're going to say UI1 for user input 1, UI2 for user input 2, and we're going to say answer for the answer. And I'm not going to define them right now. We'll let that happen later. So in this video, I'm going to prompt the user 2 times instead of just 1 time and then having them enter in 2 numbers. Think about what might be the advantage to that approach. So if we have something like finding the smallest or largest number, maybe we can compare these numbers as you enter them. So just think about that a little bit, and we'll get to it when we get there. So I'm going to prompt the user twice here. Please enter in a numerical value. I'm going to put double to remind myself what type I'm saving it as. And since I'm doing it twice, I'm going to copy that and paste it here. Then I'm going to use scanf_s give it the template, and so I'm going to store it as a double. So with doubles, actually, the placeholder is an LF for long float. Remember, floats were %F. So with double, you can just think that it's a longer type of a float. So LF is for doubles. So we can put UI1 for this one, and I'm going to copy that and put UI2 for here. And then for a sanity check, I'd like to say the user entered, and then %LF, and %LF. Give it a couple of new lines at the end. I got the placeholders, now I need the variables. So UI1, UI2. Save that. Give it a try. And let's see. Okay, UI1 is being used without being initialized. So I'm going to abort and ask why it's not being. So remember, scanf has that caveat, right? I'll keep these little mistakes in because I see it happen a lot, and it still happens to me, obviously. Okay, so 13, blah, 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 and there we go. The user then entered these two numbers. Great. So that little portion of the problem has been solved. Fantastic. So now the menu. Well, it looks like we have 8 choices here. Well, this is simply just printf statements. So let's just do that real quick. Printf, or actually we probably would like to say something to the user, prompting them to choose one. So please choose one of the following. And they would enter integers. And I'll give it a new line here. Because you have to think about how this is going to be presented to the screen. So printf, we're going to say 1. Well, I don't know, I'll put a little tab here. 1, and then a space, we'll say addition. We'll probably put a new line as well. And we'll copy this a couple of times. Change it to 2 and 3. This one is subtraction. So you can double click on words a lot of the times and it'll just select that word. It'll make things faster. So before you write this whole menu, I would start with like a couple and then see how it looks. So enter in my numbers. Okay, so please choose one of the following integers. And it's looking pretty good right now. So let's go ahead and finish this up. I'm going to just copy this first one again. Not sure if it's there. So 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, oops. And try and use your keyboard as much as you can. Find out the shortcuts online or whatever. Let's see. Multiplication, division is for the modulo operator. For remainder is 5. Find the smallest. Well, since we're only entering 2, we'll just say find smaller and find larger. And we'll exit the program if they enter 0. So if they enter in 0, it means don't do anything. So this is essentially a gigantic user prompt, right? So I'm going to say menu plus user prompt. Okay, so now we're going to await an entry. So I'll actually put another new line here because I don't want them entering it in right away, or right underneath it. I'll say printf make a selection, and then 0 through 7 are the choices. So here's another prompt, and then scanf underscore s. Now, looking at my variables, only have doubles declared. Well, these are all integers. So I can just make a new variable, and you'll do this a lot when you're programming. All of a sudden you'll be like, I need a new variable. I need to declare a new one. So I'm going to call this one UI menu. I'm not going to give it a value. We're going to give it a value down here based off of what the user enters. So we'll do %d for the integer, and then UI menu. And don't forget the ampersand. Okay. Give that a try. Okay. Menu looks pretty good. Please choose one of the following. List them all out. What if I do this? 9999. Everything works out because nothing else happens after this program, right? So we can do another sanity check. I'm going to copy this, but you can just type yours out. UI menu. And it's an integer, so we use %d. Single new line will work out. And so there's nothing stopping the user from entering something out of bounds, right? So how can you check if they entered in the values that are in bounds? Well, with an if statement, right? If they enter in something bad, you just tell them, hey, please try and, use something 0 through 7, ending program, because we don't know how to loop yet. We'll learn. So right after they enter it, we need to check for valid input. Check for valid input. And what's valid? 0 through 7. So let's kind of do this the long way at first. So if the UI menu is greater than or equal to 0, it's good, kind of. But we now need to check if it's less than or equal to 7. I don't want to confuse it. I'll leave that there. So now you need another one on the inside. If UI menu is less than or equal to 7, open up a new code block, then it's legit. Oops, forgot to close that. So now we're going to say in here, user has entered in legit input. You may continue your program here. So if it gets into here, everything is good. Everything is fantastic. But all your code must go inside of here now, not on the outside of here. Because if it fails these two checks, if it fails the first one, then you printf invalid input. Try again. Okay, and then up here, if it fails this one, it's the same error. Now we can be more specific. In this case, if UI menu is not greater than or equal to 0, it must be less than 0, right? Must be negative. Invalid input. So I can put negative and negative value entered. And then on this one, on this one up here, we expect it to be less than or equal to 7. So it must be something greater than 7. So we could say value above 7 entered. Okay, now let's give that a try. We have to try all 3 cases, right? Okay, so let's try a legit case. That worked out. So in order to speed up my testing, what I'm going to do is I'm going to comment this out with Control E-C. You just hit Control E and then hit C right after without letting go of Control. And now it should just jump straight to the menu. Whoops. It's because I have another one running. Nope. Okay. Oh, UI2 is being used without being initialized. Silly me. Let's see. Abort. I also need to comment out the stuff that uses it, which is this printf. Okay, interesting. Gonna run that. All right, so 0, that worked. 1, that worked. Oops. 7, that worked. All right, so now let's give it a negative number. -1. The user entered -1. Invalid input. Negative value entered. Try again. Okay, now something bigger than 7. Invalid input. Value above 7. Great. So these checks are doing what we think it does. So now we've checked for valid input. You can end a program by calling the return early. So you can have multiple returns in here. So if you want the program to end immediately, you can just call return and give it a value. Now to the operating system, you can give it a -1. That's usually a bad thing, saying it failed somehow or another. Let's see. All right, so this is really important. Anytime a user enters in a value, you probably want to do some range checking, some value checking, make sure they're entering in an appropriate value. Now, in this case, we check for valid input, right? So there's kind of an opposite to this. We can check for invalid input. I know that sounds weird. So let's try that. I'm just gonna move this down and write check for invalid input. Anything outside of 0 through 7. Okay, so how could we do the first one? Well, let's check to see if UI menu is less than 0. If it is, then we can say invalid input, negative value entered, and then kill the program. We can write an else if UI menu is UI menu is greater than 7. We can use this error. Value input is above 7. So now, if you remember in class, I said you do not require an else. Printf, good to go. This isn't required. If you know you're good to go after these two, you can just leave this off and the program will continue on its merry way going down. Remember, a program goes from top to bottom. The only time it'll quit is when it returns, like so, and that'll only happen if it gets into here, or if it makes it all the way to the bottom. So I'll just leave this in here for now. Or no, actually I'll just comment it out. Do that. Okay, so look how small this looks compared to the check for valid. And then to continue on, I'd have to stretch this out and put the rest of my code here. Well, with the checking for invalid, I can just immediately end the program. Otherwise, put the rest of my code afterwards. So when you're thinking about this, go ahead and try and do it the way you initially think, and then step back and just review what you did and see if there might be another way you can do it that's a little bit, I guess, more efficient typing-wise, but it's really up to you. Okay, so I'm going to take the check for valid input down here, and I'm just going to comment it out so you guys can just take a look at it when I post it. Okay, coming back up. All right, so if we can make it past these two here, we're good to go. So let me actually uncomment this with Control EU and give this a run. So if I give it a negative number, kills the program. If I give it a number bigger than 7, kills the program. Now remember, with an else if, it'll check this first one. If it gets into here, even if this return wasn't here, if it gets into here, neither of these get checked. So in this whole structure, connected with an initial if, and then followed by any else's after that if it gets into any of these code blocks, any subsequent blocks will not be checked at all. This won't even be checked. Once it gets to here and it gets in, it'll just jump back down. Unless it has a return statement in it, then it just kills the program. Okay, so for the next part is comparing the user's input to the menu. And if they do a certain choice, obviously it's going to run some certain code. So this is some stuff that you can just copy paste directly from your in-class stuff and homework. So I'll push down here and do it underneath here. Okay, now we can use another chain of if-elses. And and else's. So for the first one, we can do it right in order. We're going to check this against the UI menu variable. So if UI menu is equal to 1, if the user enters in 1, then we're going to do some addition. Right? Addition. Else if UI menu is equal to 2, do subtraction. Now this is where you can speed up some stuff. Take this chunk right here. So 2, 3, 4, 5, 6, 7, and then we'll talk about that last one here. Else the 0. So 1, 2, 3, 4, 5, 6, 7, and we have multiplication, division, the modulo. I'll talk about that. Okay, I'll just keep it that way. Find smallest, find largest, and exit. So for this last one, I didn't need to see if UI menu equals 0, because first we made sure the values are only going to be 0 through 7. If there's only one left, then obviously you can just say else. But it doesn't hurt to put else if UI menu is equal to 0. So you can keep that either way. You can either leave it as else or explicitly check that condition. All right, so for the actual arithmetic, you can pre-compute all of these ahead of time. So before you're even to here, you can have compute 7 different expressions. So what are the advantages of computing them ahead of time? Well, not compute. You can have all the answers ready. When they choose the menu, it's already been computed. But the question is, do you need to compute them ahead of time? Well, not necessarily. So you can go through the motions of, answer 1 equals blah plus blah, answer 2 equals blah plus blah. So right now, until we get into arrays, we don't have a data structure that can save multiple answers into one variable. So in order to keep it kind of easy for us, we'll only compute what they ask for. So inside of each of these if and else if code blocks, we'll do the computation there. So let's just start with addition. I'm going to set the answer, or the final answer to the expression given, and set it into our variable answer. So answer is equal to, now if we remember, we stored the user inputs into UI1 and UI2. So we're going to get down to here, so we'll just say UI1 plus UI2. That is our addition, and then we're going to print out the answer. I'm going to say which one we got into, and I'm just going to present the answer due to brevity. Let's see. Or for brevity's sake, I should say. Okay, I'm going to do that, and it's going to be similar across the board, except it'll be minus, and we'll use subtraction, we'll give it a capital, and we'll do the same for multiplication, do it there, and we'll do the same for division, divide, that. Okay, so for the modulo, interestingly enough, it requires integers. So if we do this, it's not going to work. These must be integers. So you need a special case here. So right now we're just going to comment that out. And if you want to adjust your program to just take ints instead, and then change all the %lfs to %ds, etc., then you can calculate the modulo. But right now, we're going to hold off. Remember, the modulo is simply just gives you the remainder. If you're given 5 mod 3, so if you had something like answer is equal to 5 mod 3, you think of it as how many times does 3 go into 5? It goes into it 1 time. That'll give you 3 with a remainder of 2, right? So the answer would be set to the value of 2 there. So it simply gives you the remainder when you divide. Okay, so finding the smallest and largest. Well, since we only have 2, it's quite simple. If UI1 is less than UI2, then printf, let's see, %d or %lf, sorry, is less than, or is smaller. And then do that. For the placeholder, we'll give it UI1. So that made me just realize that I have %d all over here. We want these to be %lfs, right? Oops. Boom, boom, boom. So you got to be careful. So had I run it and tested it, I would have found immediately that that was incorrect. Okay, and then so else if UI2 is less than UI1, printf %lf is smaller, and you give it UI2. Now, what's the other case? Well, if they're the same number, right? Else printf the values you entered are the same. Okay, and you can imagine it is the similar idea for finding the largest, except you'll flip that from less than to greater than, and change this to larger, and the same extra case still applies. So now if they enter in 0, and if you remember, printf goodbye, you can end a program immediately just by calling the return and returning a value. So let's just give it a try. All right, let's see what we're at. Oh, it jumped straight to the menu. I need to uncomment our code up here. Let's see, Control EU and let's see, Control EU. There we go. All right, let's try it. Let's do some easy numbers, 10.5 and 20.5. So that should be 31 if we add. So I'm going to choose 1 first, and addition 31. Good to go. All right, great. So now you can imagine it working the other ways for the other one. So I'll do 10.5, 20.5, multiplication. Honestly, I don't know what that would be. That looked somewhat right. And let's try the division. 0.5, 20.5. Division, it's a smaller number. Okay with that. Let's try find the larger number. 20.5 is larger. Looks like I need a new line on that one. And find the smaller. 10.5 is smaller. Need a new line on that one as well. And finally, the exit. Goodbye. Okay, great. So I'm going to scroll down. Where did I need to add these new lines? Right here. Just for formatting purposes. Okay, great. So now the next logical thing to think about is, well, what if I want this program to run over and over and over and over again, and I don't want it to exit until they tell me to exit? Well, we're going to get into loops in the next video.